Constraint propagation is a crucial technique used in constraint satisfaction problems, CSPs, to reduce the search space by enforcing local consistency among constraints. It involves iteratively applying constraints to infer new information about the variables, which helps in pruning inconsistent values and focusing the search on promising regions of the solution space. Here's how constraint propagation works. 1. *** propagation of constraints ***. When a value is assigned to a variable, constraints associated with that variable are applied to propagate the effects of the assignment to other variables. These constraints may restrict the possible values of other variables, leading to the elimination of inconsistent values from their domains. 2. *** consistency enforcement ***. Constraint propagation enforces consistency levels such as arc consistency, node consistency, or path consistency, depending on the specific CSP algorithm being used. Arc consistency ensures that for every pair of variables connected by a constraint, there exists at least one value assignment to one variable that satisfies the constraint with any value assignment to the other variable. Node consistency ensures that every value in the domain of a variable is consistent with the unary constraints associated with that variable. Path consistency extends arc consistency to ensure that constraints are satisfied along chains of variables connected by constraints. 3. *** iterative refinement ***. Constraint propagation is often performed iteratively, with each iteration refining the consistency of the problem representation. In each iteration, constraints are applied to update the domains of variables, potentially reducing the size of domains and eliminating inconsistent values. 4. *** conflict detection ***. Constraint propagation may detect conflicts, indicating that a solution cannot be reached given the current variable assignments and constraints. Conflicts trigger backtracking or other search strategies to explore alternative paths in the search space. 5. *** efficiency and pruning ***. By eliminating inconsistent values early in the search process, constraint propagation helps prune the search space, reducing the computational overhead of exploring unpromising regions. This makes constraint propagation an essential component of efficient CSP solving algorithms, such as constraint-based backtracking and local search methods. Overall, constraint propagation plays a vital role in efficiently solving constraint satisfaction problems by propagating constraints, enforcing consistency, detecting conflicts, and pruning the search space to focus on feasible solutions.